or how it could have x-intercepts. So the parabola, if it crosses the x-axis twice, could have two x-intercepts, or therefore two solutions. If the parabola just touches or has its minimum point sitting right on the x-axis, it would have one solution. There are instances where the parabola never touches or crosses the x-axis, and so there would be no solution. So let's talk about how that could happen. And to do that, let's look at the formula itself. The formula itself is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That is quite a lengthy formula for students to have to memorize, so it has been developed over the years for students to, or suggested over the years, for students to say the quadratic formula to the tune of Pop Goes the Weasel. I hesitate to sing to you on this screencast, so I posted for students a link to an example of Pop Goes the Weasel for the quadratic formula on our Moodle page. Also, if you just simply type in online Pop Goes the Weasel with quadratic formula, I'm sure you'll find numerous examples of how you could memorize the quadratic formula to the tune of Pop Goes the Weasel. But I will refrain from singing it for you here. The reason why we have a plus and a minus here is because we're going to actually do this problem twice. When you do the quadratic formula, there could be a potential of two solutions. So you'll do it once with a plus and then again with a minus. So many times when you're doing this problem with a quadratic formula, you'll get two answers. So how is it possible that we could get only one solution? One possibility is that you'll get a 0 underneath the square root, and so then you'd be adding or subtracting nothing, so you'll only get one answer. The other option is when you're adding or subtracting, you end up getting the same number. So you'll get two solutions, but they're identical. There is an option for you to get no solution, meaning the parabola never crosses the x-axis. That would have to take place when the square root has a negative underneath it. I hope students remember that when you take the square root of a negative, you are going to get an error message on your calculator. The reason for that is something that we're going to get to later on in Chapter 6. When you do the square root of a negative, we are able to get around that by using something called an imaginary number. But for our purposes today with the quadratic formula, if you get a negative number underneath the square root, it simply means there are no x-intercepts and therefore no solution to the equation. So we're going to do three examples together. First example is right here. Solve x squared plus 6x minus 7 equals 0. They don't give you very much to go on, do they? They don't tell you that you have to use the quadratic formula to solve it. Most of the time when we're solving, we try to isolate the x and get the x alone. But if you look at this question, we've got x squared and we've got a plain x. If we try to simplify and get those x's to be alone, we still would need to combine them. But they're not like terms, so there's no way for us to isolate an x here. So someone, probably really old and really smart, long time ago, came up with another option for us. Since we can't use algebra by adding the opposite of both sides to try to isolate the x, someone else came up with this formula for us. This is the only way to solve a quadratic when there's an x squared and an x. So that's why this formula is needed. Over the years, I have worked with many students and taught many students how to do the quadratic formula. As I've watched students work, I see that they are very prone to errors, usually related to the part underneath the square root and related to the positives and the negatives, which are rampant through this entire formula. So I have some suggestions for you on how to minimize your errors. First of all, at the beginning of your quadratic formula experience, this first number that you fill in here in the pink box should be the opposite of b. So I would recommend that when you write down that number that you either make it negative or put a big plus sign in front of it. What that does is it tells you, I've decided the sign of that number. And I'll illustrate that when we do this particular example. I know some students in the past have been told to simply substitute the numbers in and then calculate later, and I found that that is not as successful as students who simply calculate according to these four boxes that I've indicated. So figure out the opposite of b and write that down. Then you're just going to copy plus minus square root of. Then you'll calculate whatever b squared is and write down the answer. So you're not going to write down the number with a square. You're going to write down what you got after you squared it. You're going to leave the subtraction sign there, and you're going to calculate 4 times a times c. This is another area where students get confused. You're not doing 4 times a and then 4 times c. You're doing 4 times a, the answer that you get for that, times c. You may or may not get a positive or a negative number when you perform 4 times a times c. Write down whatever you get when you multiply 4 times a times c, even if you get a negative. This sign here has nothing to do with how you're going to calculate 4ac. Make sure your fraction bar is long enough to cover everything that we just talked about, so that bar should be super long. And on the bottom you're going to do the result of 2 times a. So you're not going to write down 2 times a number, you're going to write down the answer to 2 times that number. So let's illustrate that with this first example. First of all, the a, the b, and the c that go into this formula come from the equation. Remember, the equation is ax squared plus bx plus c. So those values come from the problem that they gave us. Another tip for you, students who tend to write them down separately, like I've done here, tend to make fewer mistakes than kids who just look at it from their equation. The a value seems to be missing. Hopefully students know that every variable has a coefficient or a number in front of it, even if it's an invisible 1. So the a value here is 1. B value is a 6, and be careful, the c value is indeed negative 7. Positives and negatives make a big difference when you're doing the quadratic formula. Please pay attention to those minor details. Even though they're small, they make a big difference, so pay attention to them. So let's go ahead and calculate using our 4 boxes. The opposite of b in this case would be a negative 6. Then I simply rewrite the plus minus and the square root symbol. Now I write down the answer to b squared. Go back to your original list, look at that number and square it and write down the answer that you get. 6 squared is 36. I'm going to leave the minus sign there, and now I'm going to calculate 4 times a times c. 4 times a is 1, so that's a 4. 4 times negative 7 is negative 28. And then on the bottom, 2 times a, 2 times 1 is going to be simply a 2. So that should be the first thing that students write down when they actually calculate the quadratic formula. Keep in mind that, like I said earlier, 4 times a times c may or may not be negative. You should write down what you get regardless of the fact that there's a subtraction sign there. Now let's talk about the fact that we're going to be subtracting a negative. Subtracting a negative is the same as adding a positive. So I'm going to go ahead and physically change that to plus positive. Now when I add, I have to do the order of operations here, so I need to deal with whatever's under the square root symbol next. 36 plus 28 gets me 64. So I rewrite everything else, but now under the radical sign I've got a 64. Underneath I've still got a 2. The good news here is the square root of 64 I know by heart. Square root of 64 is 8. So now I've got negative 6 plus or minus 8 over 2. This is another spot where kids tend to make mistakes. If you type this in as on your calculator as negative 6 plus 8 divided by 2, your calculator will divide first and then it'll add. And that is not what we want it to do. According to the order of operations here, this fraction bar works like a grouping symbol, so we want to add and then divide. So I'd recommend that you do this in 2 steps. First of all, write it out as one with a plus and one with a minus. So I'm going to do the top one with a plus, I'm going to do the bottom one with the minus. Make sure you add or subtract first and divide as your last step. Negative 6 plus 8 is 2, 2 divided by 2 is 1. Negative 6 minus 8, if you're at negative 6 on the number line, you're to the left of 0. If you're taking away 8, you're going to continue going further to the left. So that would be a negative 14 divided by 2 is negative 7. Keep in mind what you just got. Those are very good. They are x-intercepts. So if we think about the parabola is going to dip down somewhere, but it's going to cross the x-axis at 1 and 7. We don't know where that vertex will be, so we'll just kind of sketch it. We know the parabola opens up because the a value was a positive number. We're going to go ahead and try two more questions. Notice that on both of these, they're not set equal to 0, so we're going to need to go ahead and deal with that. I like having my x squared on the left, so I'm going to go ahead and bring the 5x and the 3 over. To do that, I have to add the opposite of both of those, and I'm going to do them both at the same time just to save time. So I'm going to subtract 5x and 3 from both sides. Now when I rewrite it on the left, make sure you write it in standard form. Over here the 5x's cancel and the 3's cancel, giving us 0, which is what we needed. Now let's list a, b, and c. Remember, kids who take the time to list it separately tend to be more successful. Again, it's an invisible 1 in front of the x squared. This time b is a negative number, and so is c. Now when I list out opposite of b, it's going to be a positive 5. If you decide not to put the plus sign there, it's still okay, you won't be counted wrong, but I like putting the plus sign there so that I know when I go back and check this question later, I decided to make that number a positive on purpose. So that helps me from second guessing myself later. Next piece you're going to do is the b squared result. Go back to your b, it's negative 5. Negative 5 squared, regardless of what you type in, is going to be a positive 25. Let's talk about that for a moment. If you type in negative 5 squared on your calculator, it's going to tell you negative 25, which is incorrect. Make sure when you type in a negative number that you put it in parentheses. That way the calculator knows that you mean to put the negative and the number together. Whenever you do the b squared on the quadratic formula, it should always be positive. Next thing you're going to write is a minus, and now we do 4 times a times c. 4 times 1 times negative 3. 4 times 1 is 4, 4 times negative 3 is negative 12. On the bottom I do 2 times a, so it's simply going to be a 2 this time. Now when I calculate on the inside of the radical, if I add the opposite there, I'm going to get 37. And unfortunately, I don't know the square root of 37 by heart because 37 is a prime number. I will be able to get a decimal answer for this, and that's perfectly fine. Just be careful when you write it. When you type it in on your calculator, you're going to say 5 plus the square root of 37. You're going to hit enter and then divide by 2. Same thing over here, 5 minus square root 37 divided by 2. And when you do that, if you round to the 10th, you get, I believe, 5.5 and negative 0.5. So we have one more question we're going to do, and that's this question here on the right. Notice the difference between this one and the one next to it. The one next to it had an x squared and an x, so we had to use the quadratic formula to solve. This one, we don't need the quadratic formula. We can solve using algebra. So I want you to watch out for that when you're working through a problem. If you can isolate the x, do it using algebra. You can use the quadratic formula on this one. It's not wrong. It just means that your b value will be a 0 because there's no number next to the plain x. But it'll be so much faster if we simply use algebra and solve for x ourselves. We couldn't do that on the previous one because we couldn't isolate x squared and x at the same time. So on this one, if I'm trying to get x alone, rather than bringing the 51 over to make it equal to 0 and then using the quadratic formula, I'm simply going to add 13 to both sides. And what I get there is 64. Now I can just square root on both sides and I'll have my answer. Make sure you put a plus minus in front. So that would be the same thing you would get if you had gone ahead and done the quadratic formula. It just would have taken us a lot longer to get there.